Hi, my name is Araceli,
And I'm Naomi.
and we're going to be talking about spring boxes and spring box construction. To provide more context, a spring is an area in the ground where groundwater surfaces naturally. There are different types of springs, and they all fall under either concentrated springs or seepage springs. A concentrated spring is a spring where water emerges from a single discharge point, and a seepage spring is an area where water emerges from several points. Generally, water coming from a spring is safe for human consumption, just like water from a borehole is, because it's naturally filtered underground. The pictures in this slide show two unprotected springs, and unprotected springs can be dangerous because they are more prone to contamination from surface water runoff or from animals. A spring box is a structure that encases a spring source, and it serves two purposes. The first is to protect the spring from contamination, and the second is to allow the spring water to flow into a pipe. There are many different ways to construct springs, and there are many different designs with which they can be built. This picture shows a spring box that is adjacent to a hill. It is important to consider building a spring box because in many developing communities, springs serve as the main source of water for community members. For example, in rural Kenya, 43% of the population gets water from a nearby spring. In Kibon, Kenya, where our project is located, we do not yet know much about local hydrology, but if there is a spring in the area, it is important that we consider building a spring box.
In this presentation, we will go over how to construct an open side structure design. So there are many different designs that we'll also go over, but for this design, um, it's when the spring source is entering more from the side. So this would be common in a mountain or a hill, and you'd want to clear the ground so that you find the single spring source as mentioned before. And then the open side structure would have the water first passing through a gravel layer just so there's some basic filtration. And then it's going to go through some large and small stones. So these stones are mostly there for structural support to the wall so that it doesn't just collapse from having an open side where the water is entering. And it also provides just another small layer of filtration. Um, then you also want to have two pipes that are going out. So that the pipe on the bottom is an outlet going to some type of storage system. So that could be a tank or maybe some other type of storage system. And on the top, you want to have an overflow pipe just in case you have too much water in the spring box. You want to make sure it's not overflowing and putting pressure on the surface of the spring box and just make sure it has an easy way to filter things. Then the top layer will be just the cover, so you want to make sure that it's slanted so rainwater and just other surface liquids can easily just roll off the top instead of stay there stationary and possibly seep into the spring box. You also want to have, after it's constructed, you want to have puddled clay so that the surface water and just other surface level contaminants aren't able to enter the spring box through the gravel layer or into the spring source. And then on top of that, you'll have mounded soil just for more structural integrity. And as was mentioned before and will be mentioned later, there's the diversion ditch, which is essentially where just a place for water and like just other surface level liquids to kind of fall into so that it's not um, sitting near the opening of the spring box and just like seeping into the spring source. Another way to design a spring box with the open side as well would be to have a collecting wall. So instead of having part of the spring box structure exposed directly to the spring, you would instead have a collection pipe that comes out of a spring box and then goes into this collecting wall that has different layers of sand, gravel, stone for basic filtration. And these designs can vary. So as you see on the left, there is a collecting wall that is at an angle, and then another one to the right of it that is just a straight, more rectangular shape. So the different reasons for the design could be just location and the local geography. So if you're on the side of a mountain, or if you have like a big rock boulder, or if you just something that would allow the spring water to be collected in with just like a different collecting wall structure, then to have that flexibility, you would have a collecting wall as opposed to directly building the spring box against a spring source.
Another common design has the spring source at the bottom of the spring box. The main difference is that all the walls are concrete with the only openings for the spring source at the bottom. This design would be chosen based on where the spring source is relative to the ground surface, and also what type of spring it is.
The final design that we'll go over is one from the EWB chapter of Illinois at Urbana-Champaign. So this design, it has walls made of CMU, rebar for reinforcement, and then also concrete. So as you can see, it has an open bottom type design, so the spring water is coming from the bottom of the structure. And the walls are slanted. In their report, they said that this was for ease of construction. You can also see in the corner that there is a pump, so that's because their spring was located at the bottom of a valley. So to get the water from their spring box all the way up to a tank just at a higher elevation, they decided a pump would be the best way to do this. And you can see that there is a shelf that the pump is allowed to sit on, so it's not disturbing the bottom of the spring box, because the bottom of the spring box has basic filtration such as sand or gravel. And yeah, so essentially this design is just a modification of the open bottom structure design that we saw earlier, just showing that spring boxes can have many different designs, and the one that you would decide on for your location is just based off of the spring source that you're working with and just other factors. So there isn't just one way to build a spring box.
When choosing the location of the spring box, it's important to look for the point source. And you do this by going to the area where the water is emerging and digging until you reach an impervious layer, which is the layer where water cannot seep down anymore. It's also important to perform water quality tests at that point to make sure that that water is safe. It's also important to avoid constructing a spring box in concave areas or areas that are downhill, because
For constructing a spring box, there are many materials that are needed. A few of them are listed on this slide, such as cement, pipes, wooden boards, motor oil, as well as general tools for construction. Some more materials will be mentioned as we go throughout the construction process, but the materials listed here are for constructing the walls and connecting the spring box through piping to some type of storage system, as well as just other tools to allow the construction of these different parts. When we're constructing the spring box, we're trying to collect all available water from the spring. So that means that we need to clean out the spring source so that there's a clear flow from a single source instead of a more diluted flow from a spring source more downstream. So by going straight to the source of the spring, we have less downstream contamination, as well as just a clear source of water, so we can efficiently build our structure to collect as much water as possible. The way we just determine the size of a spring box, it depends on how much water is needed, as well as how much water the spring would reasonably be able to produce. So if the spring source has a lot of water coming out of it, it would make more sense to build a larger spring box. Otherwise, you would just build your spring box based off of how much water you actually need. You also want to construct a fence area. This would be to keep animals away, and just maybe livestock and like smaller animals, just so there's less surface level contaminants that could enter the area of the spring box.
Water. During construction, a diversion ditch can be used to keep the construction site clear of water, which allows there to be a dry base, on which you will pour the concrete. After construction, a diversion ditch is important to implement so that surface water does not reach the springboks.
When constructing the walls of the springboks for the open side structure, you want to first start off with a wooden slab that goes on the outer portion of the springboks, as well as one that would go in the inner portion. So in between these two layers, um, eventually you will fill it in with concrete. So before you fill in the concrete, though, you put the wooden structure, and then you connect the inside and the outside layer with wire braces, as you can see in the top middle of the picture, and then you twist the brace with a piece of wood, and that just creates more structural integrity. You also want to put some temporary braces just around the structure so that once the concrete is filled in, it has more of that support. Before the concrete is placed, you want to put motor oil along the inside layers of the wooden slabs so that when the concrete is fully dried and cured, then you can remove the wood without it being stuck and attached to the concrete. The concrete will cure for about 7 days, just to make sure that it has sufficient structural integrity.
To build the springboks cover, you mix concrete, cement, and gravel and place reinforcement rods in a grid pattern. Then you pour concrete in, and as mentioned before, you want to have the lid be sloped so that rainwater will flow off. Additionally, it's important to make sure that the cover is heavy enough so that it can't be easily moved and people can remove it to take out water.
And finally, once the different components have been constructed, it will all be put together as shown. So you'll have the walls placed so that the springboks can enter through the side. You'll place the cover on top of the springboks, install the puddled clay so that there's a sealant between the surface water as well from the spring water, and maybe add a concrete apron as shown just to add more structural integrity and just make sure that the springboks is secure. Then you want to actually install your overflow and outlet piping so that water can either flow out of the springboks from the overflow or out through the outlet to the storage.
After the springboks has been constructed, it is important to disinfect the water and the springboks before use. The way to do this is to use the shock chlorination method. This method involves washing the walls of the springboks with a mixture of bleach and water, and then disinfecting the spring water itself by pouring in a mixture of chlorine solution and water. Ideally, you would test the water after 10 to 14 days for coliform bacteria, and if the test returns positive, routine disinfection may be necessary for your springboks. If not, you can wait several months to test again. After you have finished building the springboks, you can connect the outlet pipe to a storage tank, and from the tank, you can connect it to a distribution system or to another tap stand, depending on your needs. This picture shows a hand pump that was installed by the EWB chapter of the University of Victoria, which is an option for your springboks. In order to maintain the springboks, it is important to check for several conditions regularly. The first is to make sure that the diversion ditch does not have too much obstruction inside of it, and this includes plant growth or rocks and other things like that. You also want to make sure that the fencing, if there is fencing, that it is intact and that it's properly keeping animals away. You also want to make sure that the water quality is good, and if it isn't, try to find that source of contamination. It's also important to make sure that the lid of the box is airtight to make sure that animals or bugs don't enter the water. Also, you want to check that there are no leaks, and if there are, you can seal the leaks with clay or concrete. Additionally, you want to make sure that there's no erosion on any of the walls of the springboks. And lastly, You want to disinfect the spring box using the shock chlorination method mentioned earlier at least once a year. But as mentioned before, if your spring box is more prone to contamination, more regular chlorination may be necessary. Thank you for listening to our presentation. Industry or agriculture can contaminate that water if it is downhill.